So let's now look at the range. Let's look at the range. What type of functions can we be asked to find the range? What functions can we be asked to find the range? The first type is f of x is equal to h of x over g of x. Not in the root, not in the absolute. Just linear or anything. Outside the root, outside the absolute. The second one, f of x is the square root of h of x. F of x is the absolute value of h of x. F of x is a plus the absolute value of h of x. Okay, let's see how we go about this one. For this type, you find f inverse and get the domain. In terms of y. For this type, the range is going to be 0 to positive infinity. If it is positive, the way it is like that. We shall talk more about this when we bring all the families. Okay? Because for the other one, well, we could find also, let me just put it negative h of x. So here, the range is going to be negative infinity all the way up to 0. For this one, the range is 0 positive infinity. Because absolute, the least it can be is 0. Everything else is going to be above 0. And then the other one, the range here is a to positive infinity. Okay. So the other varieties that come as a result of the top two is if I have the absolute negative, the negative absolute, then the range is going to be negative infinity all the way up to 0. The sixth one is if I have f of x is equal to a minus the absolute value here. This is giving us the range to be negative infinity all the way up to a. Like that. So we'll still talk about the advanced absolute value functions and the advanced rational functions. So this one We'll talk about it in the sense of rational functions when we reach there. When we reach there. You can also be asked to find, the range of a quadratic function. That one we'll comment when we get there. We'll look at the the quadratic function soon. So when we get there, then we'll comment. So let me now look for the tutorial sheet and see what is there that concerns what we've done today. Just a moment. Okay, so okay, let's check. Let's check in sheet. Let's check in the test. Let's check in test one. This is test one for us. Let's check if we had. Did we have anything to do with? Did we have anything to do with?
So,
Hello.
there's a question that said root of x minus 4 over 2. Then they said find the domain. How do you get that one?
It said what?
Root of x minus 4.
F
then
of x is the root
over
of x minus 4 over
yes, over 4. I mean over 2, sorry.
over 2. So this falls in the category of roots of root h of x over g. So you concentrate only in the root because this number here can never be 0. So you only concentrate on the numerator. So you say x, the real number, such that x is greater or equal to 4. So interest will only be that thing which is in the root here.
Thank you, sir.
Okay. So let's check. This is test one. You remember this? This is test one for last year. And this is what was there. This question 2. Question 3 here. Okay, so this hope did not have anything to do with the domain. I don't know for whatever reason. Okay. I don't know for whatever reason. We did not have domains in here. That is interesting. Let's see if this year there will be no domains again. Have you seen? This year, last year, no domain. Someone has seen a question that gives them headache. This one. Don't worry, we'll talk about it when we come back to revising. So for now, I just wanted us to cover up the concept. I was looking for something that can dwell, that can help us get rid of the, talk about the domain. But in this one, surprisingly enough, no question to find domain in test one. Very interesting.
Sir,
Hello.
isn't it the last question when they say the same way we get the vertical asymptote, the same way we get the domain?
Yeah, but that was not direct. So I thought maybe there could be something direct.
Okay. Thank you.
Because again, if we look at 2A, and this is again test 2 for last year. Again, let's see. No domain. Have you seen? No domain. Okay. This is last year. No domain. This is what makes varieties different. You can study this whole thing of domain and then you find it's not anywhere there. Very bad. Let me check if I can find. Okay, the exam, I don't have it here. But let me check the exam for the other year. So we're in the business of looking for the domain and the range function. We have gone to the past papers, we haven't found anything yet. This is the exam for the other year. Let's check. Out of 7 questions, if there was no domain. Question 1, no domain, no range. Question 2, no domain, no domain, no range. Okay. Question 3, it's here. Let f be the function. Let f be the function defined by f of x is equal to 3x minus 1 over 1 minus x. State the domain and the range. Okay? State the domain and the range. So what is the domain here? Let's start with the domain. You get the denominator because this is now like h over g. So we got the denominator 1 on minus x and say this guy should not be equal to 0. What are we saying? We are saying negative x should not be equal to negative 1. If we divide, that means x is not equal to 1. So the domain then of f is x a real number such that x is not equal to 1. Okay? What about the range? For now, I want to limit you to finding the inverse. So let's find the inverse. Every time we did the limit, now I want us to find the inverse. So you let y be equal to 3x minus 1 over 1 minus x. Cross multiply, we'll have y minus yx equal to 3x minus 1. Put the x is one side, and the y's, the non-x is the other side. Factor out x, then we'll have that, and then divide by minus y minus 3. So the inverse, f inverse. So now I said, if you are looking for the range, find the domain in terms of y. So now you say range is equal to y, a real number, such just when you reach here, such that the denominator should not be equal to 0. That is, negative y should not be equal to 3. Divide. The y should not be equal to negative 3. So we say y should not be equal to negative 3. Like that. So that is the range. Okay. So we have finally found the function that was asking us to give the domain and the range. This was in the exam. So in test 1, it was there, except they did not mention the word domain and range. They said vertical asymptote and horizontal asymptote. The concept is similar, very much similar. Very much similar. Except don't mention it in the interval form. Okay. Let's continue searching. Let's continue searching.
So, Sam,
Hello.
if we were to say, which is question C, where they're saying let f of x equals to 3 over 1 minus 2x, then let's say we assume this question was asking about the range and the domain. We use the same principle.
Yes, it will be the same principle. After you found what they are looking. If they tell you to find the domain of this, you must first find the g of f. That's when then you can think of finding other things. Okay?
Yes, sir.
Okay. Next. Let's keep going. Let's keep going. Is there anything to do with the domain and the range? Anything domain and the range? Nothing else. Nothing else. Let's just have this. So nice. Absolutely. Remember this thing. Very soon we'll talk about them. And this thing. Piecewise functions. Quadratic functions. This is a very nice concept. Composite functions. We talked about them. Inequalities. Radical. Eventually there. These we talked about this. So we must be able to find the solution here. Use an arrow diagram to represent R. That's not a big problem. State why R is not a function. Well, we can see what's the reason why it's not a function. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's not sending 5 anywhere. Since it's a function that moves elements of S to S, it should have sent 5 somewhere. Now it did not. So it's not a function. Okay. All right. So we haven't found domains again here, but this is a past paper. Very good one. But matter. It means that there is nothing much on the domain and the range. We can put our energy there, but not that much. Because we've seen that, or if it appears, maybe it's once, one question, just a piece of it or not. So every time we do concepts like this, and then we'll go and hunt for them and see how often they come and how they come if they do come. So far we have talked about so many issues about the domain and the range. We are surprised only one question appeared out of 3 assessments. An exam, test 1, test 2. We only found it in the exam. So it's a nice concept, but you must not rely on it just because I know the domain and the range. I cannot say I'll stand up and go and write a test. No, I need to be careful. There's so many things happening. There's so many concepts. Okay. So that brings us back to our board and then say, okay, so for now we'll put a hold on this. And in the next class, we'll now go straight and start by talking about quadratic functions. So we'll talk about quadratic functions. So this should be the class for tomorrow. So kindly note that we are not going to miss any class. We're not going to miss a day, not any class. We're not going to miss a day so that we catch up, because the test is, it should be, if not, it has to be next weekend. After this weekend and the other, that's when the test is. So we can now get back and invest our energy here so that we write the test. Okay, so that is what we have tonight. Not much, but very, very important.
So,
you know,
yes, I was kindly asking for you to give me a glimpse when they say if it's not a function or a function. Like, how do you know just by looking at it?
the ordered pairs.
Yes, when they say using an arrow diagram.
So you want to check if there's any number that is mapped twice from the left. 1, 1, 1, 2, 3, 4. See if I don't do an arrow diagram. There is this one, it goes to 1. There is this one, it goes to 2. So one number is going to 2 numbers the other side. It's not a function. That's normally what we check.
Come again?
So if you had to draw the arrow diagram, you have 1 going to, so you have 1, 2, 1, 3. So you have 1, 3 going to 1, 2, 4. So 1 going to 1 and 1 going to 2, 3 going to 4. Now, because there are 2 arrows coming from 1, then it's not a function.
Thank you, sir. Thank you very much.